Welcome to 6th grade math. This is for lesson 153. We're on, this should be Thursday, so we are on pages 275 and 276. So we do have you have a speed drill it's a minute and 30 seconds, and so I'm going to start with some flashcards and then let you go to your speed drill, and then we're going to look at time around the earth, okay? All right, so first of all, 7 times 6. 42, 12 times 3, 36, 10 times 8, 80, 12 times 12, 144, 7 times 12, 84, 10 times 11, 110, 3 times 7, 21, 6 times 9, 54, 9 times 12, 9 times 12 is 108, 5 times 5, 25, 5 times 10, 50, 12 times 6, 72, 7 times 8, and 7 times 4, 28, 6 times 11, 66, 7 times 6, 42. All right, I messed up a couple of those, sorry. All right, so I'm gonna let you go ahead and take your quiz, your speed drill, and then when you come back, we'll get started. All right, I hope you did well on that. There is also homework for this lesson. It is on page 386 and lesson 153. So we're going to go ahead and take a look at the time around the earth. Calvin lives in San Diego. The President of the United States is to make a live address from Washington, D.C. to the nation at 8 o'clock. However, Calvin's dad says that they must get home early from baseball practice so that they can hear the president at 5 o'clock. Why must they be home at 5? Okay, so does anybody know why they have to be home at 5 when the speech isn't supposed to be till 8? The time difference, right? The time in California is 3 hours earlier than the time in Washington, D.C. So we learn about the meridians and the longitude on the globe to help us understand the time differences in the world. Okay, on a globe, let me grab my globe. Okay, so on our globe, there are lines of longitude. They run north and south, but measure distance east and west. Both parallels of latitude and meridians of longitude are used to locate places on the earth. Okay, so every line that goes up and down and side by side, they'll meet at a certain point, right? And so that tells us where something is. That's how ships can navigate. That's how airplanes can navigate. Knowing these things can be very helpful for you later on. And in knowing the time zones, it's also helpful. So meridians of longitude are related to time. The Earth takes 24 hours to complete a full revolution of 360 degrees. That means in 1 hour, it rotates 15 degrees. To rotate 1 degree takes 4 minutes, okay? So in 4 minutes time, we've rotated 1 degree, okay? So multiply degrees by 4 to find time needed for the Earth to rotate that many degrees. Simplify minutes if necessary. Okay, so put that up. All right, so if we had, I'm just gonna write it down here. We're gonna get to the time zones in a minute. If we want to know how long it takes for the world to rotate for 17 degrees and 71 degrees. What did it just say? So we had to multiply by a number. How much does it take for 1 degree? 4 minutes, okay? So we're gonna multiply by 4, okay? So 4 times 7 is 28, carry the 2, 68. Okay, so it takes 68 minutes for the Earth to rotate 17 degrees, okay? Let's see how long it takes for it to rotate 71 degrees, okay? And 68 minutes is really an hour and 8 minutes, right? So we can convert that into the hours if we have that. 4 times 1 is 4. 4 times 7 is 28. So it's 284 minutes, okay? This one's a little trickier to divide. We're going to divide it by 60 because there are 60 minutes in an hour. So let's see, 6 into 28 is going to go 4 times. Okay, so it's going to be 4 hours and 44 minutes, okay? So whatever your remainder is, this is your hours, and as long as it's less than 60, that's your minutes, okay? And so 4 hours and 44 minutes it takes for it to go 71 degrees. Okay, so that's how to convert that. That's what you're going to be doing on those problems on the bottom of the first page. The Earth, let's see, imaginary lines that run from the north or to south pole are called meridians of longitude. 0 degrees longitude passes through Greenwich, England, and is called the Prime Meridian. Okay, so the Prime Meridian passes through Greenwich, and so when Greenwich is exactly in line with the sun's rays, the time there is noon. Traditionally, noon is written at 12 m. However, it is commonly written as 12 p.m. This time, Greenwich Mean Time, GMT, and was the basis for time around the world before 1970. GMT is based on the rotation of the Earth, which can vary slightly due to the Earth's wobble. Therefore, Coordinated Universal Time, UTC, which is based upon the atomic clock, is now our standard time. UTC loses no more than 0.0006 zeros and 1 second in 1 year. Okay, so that's not very much for it to lose. Until the age of modern travel, communities regulated their own time. However, in 1884, an international conference established 24 time zones. 12 are east of the Prime Meridian and 12 are west of it. The 12 zones, east and west, are half zones and are separated by an imaginary line called the International Dateline. The IDL is opposite the Prime Meridian. Okay, so you can see that on the globe there on your page, that the International Dateline, the Prime Meridian are opposite of each other. Okay, so we've got our time zones that relate to the United States. Okay, so we have, we look at the Hawaiian Aleutian, Alaska, Pacific, Mountain, Central, and Eastern. Okay, so I'm going to erase this so we make sure in our whole room. If it is 2:15 p.m., and pay attention to if it's a.m. or p.m., because sometimes you're going to have to go, if it's like 1 o'clock, you may have to go back to noon, and so make sure that you're paying attention to that. If it's 2:15 p.m. in Alaska, we want to know what time it is everywhere else, okay? So first of all, Hawaiian Aleutian is 1 hour earlier than Alaskan time. So 1 hour earlier is what time? 1:15. Don't forget the minutes on it, okay? Because it is exactly the minutes. We don't drop those, okay? If it's 2:15 p.m., the Pacific time would be what time? 3:15 p.m. Okay, and Mountain time would be 4:15 p.m. What time was Central? 5:15. And Eastern would be 6:15. Okay? So at 1:15 in Hawaii and the Aleutian Islands, which are southeast of Alaska, or southwest of Alaska, I'm sorry, they would be probably have finished up lunch not too long before this, right? When over here in the Eastern time zone, they were either eating dinner or have finished dinner. Central's probably getting ready to eat dinner or eating dinner. Mountain would only be eating dinner if you're an elderly person, because they like to eat dinner early. Pacific would not be eating dinner. They might be getting a snack, right? And Alaska might be getting a snack too. So you see the difference in the time zones vary on what they'd be doing at that time, okay? All right, so you want to make sure that you put the hour, if there's a minute, if not, just put point or colon 00 and AM or PM, okay? Or if it, well, it says it in one of them. Sorry, noon can be written for 12 o'clock noon. Midnight can also be written for 12 o'clock. So this is 12 o'clock PM and 12 o'clock AM is midnight. So that can get confusing, so that's why we let you put midnight or noon. Okay, so if it's noon in Hawaii, what time is it in Alaska? 1 PM, right? Pacific would be 2 PM. Oh, I forgot the zeros. Writing too fast. 3 PM. Again. All right, guys. 4 PM. And 5 PM. Okay? So they're eating lunch, they're eating dinner. Central might be eating dinner if they're older. Okay? All right, so this is really the simplest way to do it. Let's see. Let me just see. Time zones, including the Prime Meridian and the International Dateline, differ from meridians of longitude in that they are not straight lines. Time zones are made to work with boundaries of states and countries as much as is reasonable. Okay, so that's why you'll see the lines between them be crooked or something. It may go around an island or something, may go with the border of a state. A traveler going east across the dateline must set his calendar back 1 day. The westbound traveler across the international dateline moves ahead 1 day. So you see that there's a whole day's difference if you go across the international dateline. That's why it's called the international dateline, is because it's where it separates the days. So if you go back, so like when my parents went and visited Australia to see my grandparents, they had to go across the international dateline. So they went back an entire day, which was really odd, but they did. And when they came back, they lost a day, which is even weirder. From the second Sunday in March to the first Sunday in November, many regions use daylight savings time, DST. This means the clocks are set 1 hour ahead of the standard time for that zone. Hint, spring ahead in the spring, fall back in the fall, okay? So we've done that. All right, so section 1, you are just multiplying these by 4, right? Okay, so, and then if they were like our, the ones I did on the board, change that to hours and minutes, unless it's less than 60 minutes, change it to hours and minutes, okay? And so I want you to do all of these. It's good practice. And then section 2, we're going to do all of it because that grid will be helpful to you guys. Just pay attention to AM and PM, and you'll be good with that. You can pick one of the 2-story problems. Wow, Morgan, you could either pick one about your dad or one about you. Okay, that's interesting. For 4, do all of those. Those are pretty simple. But then for the review, let's see. I want you to pick one of the degrees to do. So one of section 5, 2 of section 6, and then of section 7, pick 4 total, okay? And then do the homework for this lesson, and you'll be done with that. So I will let you go, and have a good day. Have a good time.